So let's work through a few more examples of using prime factorization to come up with the greatest common divisor and the least common multiple. So here we have four numbers that have already got their prime factorizations, so we can work with them directly. And to get the greatest common divisor of, and let's do 36 and 63 first. We're going to look at each of the factors, the prime factors, and we're going to include the smallest of each one. Now, previously, when we didn't have a prime factor in one, we would add the prime factor raised to a 0. So in 36, we have a factor of 2, and in 63, we don't. So 63, the prime factor of 2 is 2 raised to the 0 power. There's 0 2's, and that is any number raised to 0 is 1. And so it didn't change the value. When you multiply by 1, it doesn't change the value. Well, we can do that same thing without actually writing it down, because we can look at it and we can say, hey, we need the least number of them. So we look at the 2's. There's 2 of them in 36, and there's 0 in 63. And the least is 0. So we'll include 0 in our greatest common divisor. We look at 3's. There's 2 of them in 36. There's 2 of them in 63. So we're going to, the smallest number of 3's is 2, so we're going to include that in our greatest common divisor. And then we look at 7's, and there's 0 in 36 and 1 in 63, so we're going to use the least, which is the 0. So that leaves us actually with 2 3's is what our greatest common divisor is, so 3 squared is 9. So our greatest common divisor between those two numbers is 9. How do we do with the least common multiple? It's very similar. And again, we write it this way, 36, 63. But this time we're going to choose the largest of each of them, right? And so of each factorization. So there's 2 2's in 36, 0 in 63. So we're going to do the largest, which is there are 2 2's. And so that's our largest one, and that's what we're going to use. The next one is the 3's, and we have 2 3's in each of them. So the largest is 2 3's. And then we look at the factor 7, and the largest number of 7's is the 1 in the 63. So that's 7. So our least common multiple is 4, right? 2 squared is 4, 3 squared is 9. And so we can do this math. We do 2 squared is 4 times 9 times 7, and we get 252. So there's our value for least common multiple. Now notice these are with really small numbers, right? But we can do them with not quite so small numbers. These are still not large numbers, but they're not small and are not as small. Okay, so what we can do here is the same thing, but now we'll greatest common divisor of 2100 and 2646 is we're going to take the fewest. 2 2's here, 1 2 here, so we're going to do the 1 2. 1 3 3 3, so we're going to take the 1 3. 2 5's, 0 5's, we're going to take the 0. 2 7's and 1 7, we're going to take the 1 7. So what's the greatest common divisor of these two numbers? It's 2 times 3 is 6, and 6 times 7 is 42. So the greatest common divisor of those two is 42. And notice how that was really pretty quick to do. And you can imagine that if you had one with twice that number of prime factorizations, it still wouldn't take very long to do that comparison and be able to do that. And so this is a really efficient way to figure these out. And this is efficient because we already have the prime factorizations. Now for the greatest common or the least common multiple, we're going to take the most. So the greatest number of 2's is 2 of them. And the greatest numbers of 3's is 3 of them. And 5, the greatest number of 5's is 2 of them. And the greatest number of 7s is 2 of them. All right, so what's the least common multiple? Well, we just multiply all these together. So we've got 4, and then we've got 3 cubed. So that's 27, 25, and 49. So let's go ahead and multiply that. 4 times 27 times 25 times 49. And the least common multiple is 132, 300. So 132, 300. There you go. Now you don't have to have matching numbers, like they don't have to have the same number of digits. So we can mix and match, and you can really just do this with any values. So let's go ahead and find out what they are with, oops. Let's take the 63 and the 2646. And we can find out what that is, right? What's the greatest common divisor of 63 and 2646? And then also do that with the greatest common divisor and the least common multiple. So again, same process. What's the fewest number of 2s? There's 0 in 63. What's the fewest number of 3s? There's 2 in 63. Then the smallest number of 7s is 1 of them. And so that gives us the greatest common divisor, right? Pick the least of each value. So that is 9 times 7, so 63. And we were able to find the greatest common divisor of different numbers. And you can actually do this with any combination of numbers when they've already got that prime factorization done, right? So the least common multiple of 63 and 2646. And here we take the greatest number. So the greatest number of 2s is 1. The greatest number of 3s, there are 3 of them. The greatest number of 7s, there are 2 of them. Okay, so we take 2 times 3 times, oops, not 3, wrong one, clear that. 2 times 3 cubed, which is 27, times 7 squared, which is 49, and we get 2646 as our. Now notice that's interesting, right? Because that's the number itself, which means 2646 is a multiple of 63. So there you go. We found greatest common divisor and least common multiple when we have the prime factorizations.